We're sponsored today by Forward Networks. Enterprises rely on Forward Networks' network digital twin for unified, trusted automation across distributed hybrid networks. Forward Networks' network digital twin ensures connectivity isn't disrupted, security posture is unchanged, and compliance is maintained at all stages of change management. Forward Networks' digital twin is the difference between risky automation and operational certainty. Learn more about how to protect your network and your sanity with Forward Networks at forwardnetworks.com/packetpushers. Welcome to Packet Protector, the podcast at the intersection of networking and security, and in this case, wireless networking and security. I'm Drew Conry-Murray here with my co-host Jennifer JJ Minella, and recently JJ gave a talk on wireless security misconfigurations at the Wireless LAN Professionals Conference, or WLPC. Her presentation uncovers some hidden misconfigurations you should be aware of if you're running a wireless network. So we'll talk about some SSID issues, radius fails, EAP, and JJ is also going to get on a sandbox about some Wi-Fi 7 issues regarding vendor security implementations or lack thereof. So JJ, you're our guest for the day, so I guess I have to treat you like a guest instead of my co-host. I don't know if that's any different.
Let's see what this feels like.
So first off, you've been involved with WLPC. Can you give us a little background on what it is, what the conference does, and that kind of stuff?
Yeah, that's the Wireless LAN Professionals Conference, or Wireless LAN Pros Conference. And I'm, in the grand scheme of the conference, I'm relatively new to it. I've been going for the past, handful of years. Typically there's one in Phoenix around February-ish each year. And then one somewhere in Europe. I think it's moved around, but since I've been there, it's been in Prague the past couple of years.
Nice.
And yeah, and they've expanded into some Spanish speaking areas in Spain and Mexico as well. But yeah, it's a conference for, wireless LAN professionals or any network engineer that's responsible for Wi-Fi.
Uh-huh. Okay. And one of the things I think that folks should know is that there's some pretty detailed technical presentations that go on, and obviously it's great to be at the event, but if you can't make it, they publish all of the presentations and talks on YouTube, right?
Yeah. It's all free online, all of them from every event every year. So they have a fantastic repository of content.
Yeah. So if you go check it out, there's all kinds of stuff. And yeah, you can see it free on YouTube. We're going to talk about your presentation specifically. So you broke your presentation out into three parts. We'll start. The first one was on SSID misconfigurations. And the first issue you raise is this idea of peer isolation, which is not configured by default. What is it, and why do I want to isolate my peers? Shouldn't I be embracing my peers?
Well, it's not about isolating them. It's just kind of isolating them from each other so that if something happens to one, or if there is a malicious user or application running, it doesn't have direct network access and adjacency to the rest of everything else on the Wi-Fi. So it's one of those things.
Is peer here in this case, another client connecting to an AP, or are we talking about APs peering together? What specifically?
Yeah, it's confusing terminology. So when they first came out with that feature, which it used to be on by default, used to be enabled.
The isolation used to be enabled.
Yeah, It was called interstation blocking. So that was a little more clear. Blocking between, as a networking person, I thought it was more clear because we also used to have peer-to-peer application control in wireless as well. And so I don't know. But anyway, most of the vendors are calling it something like peer isolation at this point. It just means that, so on an SSID and Wi-Fi, all of that is a layer 2 broadcast domain.
Okay.
So if if you're joined on a network and I'm joined on the same SSID, unless we click the little box for the isolation, I can directly access you.
Okay. I'm on that network and you could establish some kind of connection with me?
Yeah. So if I pop open anything, Nmap, Nessus tool, whatever kind of tools you might have for scanning, you're just sitting on it like you're sitting on the same VLAN, basically.
Okay. Okay. So it's not necessarily that the traffic would be unencrypted. It's all still encrypted, but I can see who's on there, get some packet header data and so on from everybody also associated with that SSID.
Yeah, I mean, there's some stuff you can get over the air even if you're not on the SSID. But my concern with this is let's take malware. if you don't have some type of blocking, if you've got like a guest network or BYOD or whatever, and all of those things can see each other, then if I come in and I'm infected and that application, a malicious application, starts spreading through, it has that layer 2, and in some cases layer 3 adjacency if you haven't blocked that into those other devices if we don't have some mechanism to control that.
Okay, so peer isolation would prevent that, meaning essentially it looks like I'm on my own VLAN to the device?
Exactly. Okay. Exactly. Yeah. And there's different, there's different ways, but the easiest thing, especially for like a guest network, is to just check that little box. On most products, it's an easy box to check. On a few of them, it's a little bit more complicated. But yeah, I mean, it's, on internal networks, you can't just go check the box because there are lots of applications that require that. And it doesn't mean two things can't get to each other. It just means they're going to have to go through some type of filtering or control. Something is making an intentional decision that it is allowed or is not allowed to get to something. Okay, so you're saying this feature is by default not configured in most vendor wireless APs? Currently, correct. Because, it used to be, and then we had Apple stuff come in. We had Bonjour, we had MDNS, we had all of those zero conf protocols that just kind of all want to talk to each other. And so just, it was easier to not enable it and reduce the number of support tickets. And then it's unbelievable. I mean, the number of organizations that don't block that. I mean, I've taken like network testing tools like, NetAlly's Cyberscope or something like that, like little handheld tools, when I was just doing testing and walking around cities. And there's been whole, city governments, municipal governments that I could get on the public Wi-Fi, even reach back in through and see their wired infrastructure in their offices. When we were at RSA together a couple of years ago, we were in the SOC. Remember how we had, because I think we had NetAlly scan the whole network there as well. And we got our hands slapped a little bit for that. But yeah, that was my bad. But they also didn't have this peer isolation on. So if you got on, and it wasn't RSA running the network, it was that they were using the venues network. So Moscone had everything open. Yeah. And so if you joined that network, you could see every freaking thing else on that network. Okay. So you mentioned internally, you maybe want to think more carefully about activating peer isolation? Yeah, because if, don't go crazy. I would prefer to see it enabled everywhere that it can be. But there's going to be use cases where, somebody's using some of those talkie apps. We're using Bonjour. That's not limited to Apple. Windows does it too. Some Android apps do it. So, if your organization, now there's ways to filter. That's probably a whole different episode right there. Or you can watch some WLPC videos because there have been several fantastic speakers talking about like managing various multicast and broadcast protocols over wireless, including, MDNS and some of these more consumer grade protocols that sort of run and subvert some of our other controls we have in the enterprise. Okay. But in general, guest network or public facing Wi-Fi, maybe this is a good place to start peer isolation. Yeah, absolutely. Okay. Moving on, another misconfiguration you talked about is that you see MPSK without segmentation. I'm guessing the PSK in there is pre-shared keys, but what's the M and what are we segmenting and why? Oh, well, all of the vendors, and this is a can of worms I'm not going to open right now, but with WPA2, personal or passphrase, so that's when you just type a passphrase in to get on wireless. The WPA2 generation of security basically has a security flaw in it that lets us reverse the key back out because the passphrase is the key. And so we can use unique passphrases to create micro segments sometimes. And when I say sometimes, this is very vendor dependent. And the M means multiple, so multiple pre-shared keys, but different vendors call it different things. So there's MPSK, which is a multiple pre-shared key. There's PPSK, which is personal pre-shared key. There's IPSK, which I forget what that stands for. There's DPSK, which is like dynamic PSK. There's UPSK, which is like unique PSK. The vendors, because this is not standard, right? The vendors just have their own implementation of this.
Okay.
And I think a lot of times, professionals turn that, they use MPSK or PPSK. A lot of vendors give you a little option with a little checkbox that says, hey, create a little mini segment based on that pre-shared key. So if you're thinking like, whether it's, in an enterprise environment where you have like, oh, all of our building facility stuff uses, this passphrase, and my, communications and streaming stuff that's connected in the offices or meeting rooms uses this other PSK. So you can start to divvy them up like that. Or it could be like in a university where you've got students, if each student has their own PSK, they can join their own stuff, and that stuff can talk to each other. But one student can't get to another student's stuff.
Okay, so this is a kind of, it's a micro-segmentation capability.
It is. Yep.
But you see that deployed without segmentation off.
Yeah, not all vendors have an easy little checkbox. So sometimes you have to have separate, software or licenses or an additional area of configuration to actually segment that. Or if the vendor doesn't support that micro segment based on the passphrase, you can also go back, see part A where we were talking about do that peer isolation. So if you want to do MPSK, but your vendor doesn't natively support, segmenting based on that, you can still block the traffic between those things by just clicking that peer isolation button.
Okay. If I was going to do one or the other, is there one that would be more impactful to start with, or is it based on sort of the organization, the risk profile and all that?
Yeah, I think it depends on, your architecture, and I hate to say it depends all the time, but I think to say like on a public guest network or like a BYOD network, it's an easy thing to just enable that peer isolation. If your product doesn't natively support MPSK segmentation, then maybe you want to do the same thing. But it's just, the one thing is we want to increase security, but we don't want to break things. The other challenge is this whole construct of multiple pre-shared keys is tied to WPA2 generation of security. We're at WPA3 now.
Right.
And it's been out there for, almost 7 years. And that is where we need to be, but you can't do MPSK, PPSK on WPA3 personal, because remember what I said was the whole idea of WPA2 MPSK was we were kind of exploiting a security flaw in that protocol in order to do that. And actually, I really like, so speaking of the WLPC videos, Stephen Orr, who's the security work group lead for Wi-Fi Alliance, he's also involved in a lot of IEEE stuff. Distinguished Cisco engineer, just super smart guy. His presentation at WLPC Prague in October was on security stuff, and he kind of dug into this as well. So that's a fantastic video to go watch. And they're short. They're like these are like 10 and 20 minute videos. They're not hour long.
Right. Yep. Yeah, so we'll have a link to that Stephen Orr video in the show notes.
Yeah.
So just to wrap this one up then, MPSK is an issue if I'm still at WPA2 on my WLAN.
Well, you can use MPSK if you've got WPA2. If you want to move to newer security with WPA3, which we recommend, what makes the most sense is to just leave all of your WPA, and I'm talking about passphrase networks. So I'm talking about passphrase networks. If you're using 802.1x, it's an easy jump to WPA3.
Okay.
You can just do it. But on a passphrase based network, the recommendation is to, especially if you have like IoT-ish, lesser capable, devices, phones, laptops, tablets are pretty good. They'll do whatever. But if you have other stuff on your passphrase network, the best thing to do is just leave it like it is, like leave the SSID like it is, make a new SSID that's a WPA3 passphrase network with a different passphrase that's not used anywhere else, and then start to move things over if they can be moved. And there's a long list of reasons why some endpoints won't work either with WPA3 or even with the WPA3 transition mode, which is the T and the M there are capital. This is a mode of operation defined by the Wi-Fi Alliance that supports both generations at the same time, WPA2 and WPA3. But there's a long list of reasons why an endpoint may not connect to a transition mode network. I won't dig into that now, but it has to do with like the way that the beacons are advertised. There's multiple AKMs and new AKMs and ciphers there. So that's why we just say, look, don't break stuff. Leave your WPA2 thing where it is. Start a new WPA3 network for passphrase, and then systematically move things over. Because if something falls off the network, if you turn the WPA2 network into transition mode and something doesn't like it, you're going to have to go, it's not like you're going to have no indication. There's not going to be a log error in your wireless product that says, oh, this thing didn't like this and now it's gone. You're going to have to know that it was there, know that it's gone, and then go find it.
Okay.
And good luck.
Right.
Good luck with that. I couldn't even pull that off in my house. And I don't have that many things in my my home network. I lost a couple devices during the upgrade.
Okay. So proceed with caution and have a very detailed list of your inventory.
Yeah.
You also talk about ways to segment wireless networks with SSIDs. But then, if you're taking that step, sometimes organizations fail to go to the wired side and then apply that segmentation. Can you talk about where these mismatches happen and what to do about them?
Yeah, this is one of the funnier things. And I'm not picking on anybody. I realize we're all doing the best we can do with what we've got. And we've a lot of times got bigger fish to fry. But my goodness, people, like the number of times I've walked in and there's been like, there's separate SSIDs in wireless networks for things. And then on the back end, one of two things happens. On the back end, those are mapped to the same VLANs, so they can still all talk to each other. Or they're on different VLANs, but there's no ACL between the VLANs. Like there's no, I'm commingling VLANs and ACLs.
Right.
Most people apply IP subnets to VLANs, right? So, but there's nothing filtering traffic between those two, right? There's nothing saying VLAN 12 can't get to VLAN 46.
Okay, so even though you've isolated using VLANs, they're still able to cross those VLANs essentially to connect to each other or see what's happening.
Yeah, so basically sometimes we segment really well over the air, but if there's a path, a layer 2 or layer 3 path back to other stuff on other networks, you're still able to get to those things if you don't segment them. And
how would you find that out?
Well, like me find it out, or how would...
I mean, like if somebody's listening and they're like, I want to go check.
Yeah. Well, start with your wireless product. I'm a huge fan of network diagrams. I know not everybody thinks the D words are good, but I like the D words, documentation and diagrams. And look, seriously, like just a quick little side note. If you don't like Visio, that's fine. Use like Draw.io or Lucid Chart, something, anything, right? Literally anything. Yeah. It doesn't have to be, a masterpiece, and it doesn't have to be a big Visio file. But, look at what each of the SSIDs, is it mapped to a VLAN? And now sometimes we haven't talked about this yet. Sometimes if there's a radius server involved or a NAC server involved, network access control, sometimes they're doing dynamic, VLANs on the back end, and that's great. But if it's just a static VLAN, then you want to just see, make a note of that. Go look at the other SSIDs, see which VLANs they're mapped to, and then look on the switching side. And depending on your architecture and your infrastructure, your access control lists are going to be applied at that layer 3 boundary. So, whatever is doing the routing, right? Your default gateways. So that you look at those and you go, okay, well, here's this is the default gateway configured for this network. That's the default gateway configured for that network. What filtering is applied between them, and if it's going to a firewall, you do the same. So wherever the traffic filtering is supposed to be happening, I was taught to follow the packet. So I go from what is the client's IP address, what is its subnet mask, what is its gateway, and then hop through from there. And I'm sure there's tools, that simplify that. I don't know what they are, but I'm sure they exist. Drew's looking at me like, and they are.
You can hit us up at packetpushers.net/FU if you have some suggestions, and we'll drop it into a later episode. But yes. Okay, so it's maybe a little bit of detective work, maybe a little bit of brushing up on your diagrams to make sure they're up to date, but it's not like a week-long project or something.
No, I mean, not unless you just are huge and sprawling and have weird stuff happening places. I mean, it's definitely, in my prior life, I had to go into other people's environments and document everything and pull it. So if you're looking at a whole environment, it can become challenging because you have routing switches multiple places. It's not like you go look at one routing switch probably. Uh-huh. So, and it depends on if you're dropping the VLANs locally so that they're like access ports, or what would Cisco call that? Hybrid port, where there's some things that are tagged and some things that are untagged. But if you extend the VLANs for those client devices out to the edge switch port where the access point is, you have a lot more work. If you're in a controller or a gateway situation where you're tunneling the client traffic to one central point, now you just need to look there.
Okay. Yep. Got it. All right. So that was part one of your talk. Part two was on radius fails. And the first up is the radius shared secret. Can you talk about what the shared secret is, what the radius server, what other objects the radius server is sharing the secret with, and what the problem here is?
Yeah, this is a funny one. Another funny one. So the radius shared secret is just like a text string that anything that's doing the authentication, so your switches, routers, access points, that's talking to the radius server, when it communicates to the radius server needs to know about it based by either its IP address or its host name, and then it gives the shared secret as kind of like a password into, hey, I'm authorized to ask you, radius server, for this. Okay. But that's not encrypted. And so one of the things, now there's nothing that tells you that, you just have to kind of know. So one of the things that I see a lot when I've worked with clients, because a lot of my work, you're literally sitting right next to the client. This is, with COVID, before COVID, whatever, virtually sitting with them, logically sitting with them. And a lot of times what they do, if they're doing the work, is I realize they have taken one of their root passwords or super secret, squirrel admin passwords, and they're using that as the radius shared secret.
And then that is being passed in the clear.
Yeah. Okay. Everywhere.
That's a problem.
Yeah. So that's kind of funny. Now we have some, we have options to use like RADSEC and encrypt things, but that's not as widespread and common as I would want it to be. So other weird tips and tricks I've used with shared secrets is you can either just use a random, generator, because frankly, it doesn't matter. It's sent in clear text. So you just have to assume it should be unique to this purpose. And you should just assume that it's known to a malicious actor if somebody's able to, sniff your traffic. But you can do things like, use MAC addresses, or just come up with a string that's specific to, to the radius use case there. But yeah, don't use any real passwords for that, because it is sent in clear text. It will get picked up by other tool. Even if there's not malicious actors on your network, if you are doing other things with traffic inspection, it's going to be floating out in various, logs, reports, tools, dashboards that you may not want it in.
Okay. So if you aren't going to go with RADSEC, which is using TLS to encrypt communications among radius and devices, whatever you're using for the shared secret, make sure it's not something you're using somewhere else in another part of the network for sensitive things. Yeah. Okay.
Yeah. I love RADSEC. So if you can do RADSEC, I would say do that now. RADSEC.
And then you also talk about EAP, or the Extensible Authentication Protocol. EAP's a framework to give folks authenticated network access, but my understanding is EAP is actually not an authentication mechanism, so it's typically paired with something else. Is there anything else you want to say about EAP before we get into the issues? Or
Well, it's a framework, and so the EAP protocol, you can kind of think of it as like a structure or a skeleton that you can plug in different types of authentication mechanisms. So the things we plug in are like username and password, or certificate, user certificate, device certificate, or tokens. And then in some cases, you can layer those so that you're authenticating against maybe a user and a device, or we don't really do this on Wi-Fi, but you could do, a certificate and some type of multi-factor code.
Okay, so EAP is the framework. It's not the actual authentication mechanism. You have to use something along with EAP, yes?
Well, so it's the authentication protocol, and it is the thing doing the authentication. It's just that the EAP methods or EAP types to fit into that framework of you can swap them out, right? Like,
got it. Okay.
Yeah.
Okay. So in your talk, you mentioned naked EAP. So please explain what is naked EAP.
Well, okay. So what is not described well anywhere, I don't think, other than maybe, my book and a few other specific places, is that when people talk about EAP, they say, PEEP or TLS, or they'll say MS-CHAP. And the truth is there's actually inner authentication mechanisms. So MS-CHAP v2, for example, is an inner authentication. It's the actual authentication mechanism. And that's username and password. Then we put that inside of something that's a secured tunnel to pass that authentication traffic. So typically, just by default on a Windows machine, that MS-CHAP v2, if you're doing username and password, would go inside of a PEEP tunnel, PEAP, protected EAP. But it doesn't have to, but it should. So the other
so this is another one of those configuration issues where you think, oh, I'm using MS-CHAP, so I'm okay, but I didn't click the use PEEP.
Yeah, it almost kind of looks, it depends on the product that you're using. And this is the other beef that I have with all of the vendors, is they don't make it clear. So, in my presentation, one of the examples I show is Microsoft NPS server, which is just the default. Like if you have a Microsoft server and you're like, I want to do Radius, and you spin up a Radius service, it's an NPS server. So when you do that, it will, depending on the version you have, but typically it like auto checks all of these deprecated and legacy EAP methods that can be sent untunneled, not in a tunnel.
Okay.
And let's say you did want to do PEEP and MS-CHAP v2. What most people do is they, in the main little window, I'm like gesturing here, in the main little window.
Drawing in the air.
Yeah, I'm drawing in the air, like the little white window, like we all know in Microsoft, right? You put stuff in. You'll put in PEEP, and then typically people put in MS-CHAP v2 because it looks like, yes, PEEP, MS-CHAP v2, that's what I'm doing. But what that's actually doing is letting an endpoint or a user or device authenticate with that MS-CHAP v2, with that username and password, not inside of a protected tunnel. It's like a weird nested thing. You have to actually go set PEEP and then go into that as a submenu and configure MS-CHAP v2 for a proper configuration.
Okay. Yeah, and just this, we're joking about drawing windows in the air, but in your slides, you do have some images, and we'll have links to the slides if folks want to go and actually see what you're talking about. Okay. Yeah.
So the long story short with that is that some of the EAP methods, and I think the username and password with MS-CHAP v2 is the squishiest. Some of that gets passed in clear text. Typically not the password if you're using MS-CHAP v2, but the username is. And so, different people have different takes on this. There are some of the Edgerome, institutions using Edgerome. They're like, I want to see the username. Okay, fine. But then if you look at an enterprise, they don't want that exposed. So, so anytime we have the ability to put like a secured outer tunnel on something, so PEEP is a tunnel, TTLS is a tunnel, TEAP, TEAP is a tunnel. And then we can we can mix and match and do whatever we want to. We can put any of the inner authentication mechanisms inside of any of the tunnels. Now, what the endpoints support natively, varies by endpoint. I mentioned Microsoft tends, by default to do PEEP. If you're doing MS Chat v2, Microsoft and everybody's trying to move away from username and password into certificates. So we're trying to get over to TLS, which in most cases, if we have the option, I would still want to tunnel that inside of something like a TTLS tunnel. But either way, we're moving towards certificates, but a lot of people are not on certificates.
Let's pause for a word from sponsor Forward Networks. Forward Networks creates a digital twin of your network. Enterprises rely on Forward Networks for unified, trusted automation across distributed hybrid networks. Now, if you think a digital twin is just a network map or an inventory list, think again. Forward Networks Digital Twin is a mathematically precise digital replica, able to model all config and state data on every device and trace every possible packet path. With Forward Networks Digital Twin, you can ensure that connectivity isn't disrupted, that security posture is unchanged, and compliance is maintained at all stages of change management. That's why enterprises rely on Forward Networks for unified, trusted automation across distributed hybrid networks. With Forward Networks Digital Twin, you can eliminate change-related outages and the subsequent headlines. That's why Forward Networks Digital Twin is the difference between risky automation and operational certainty. Learn more about how to protect your network and your sanity with Forward Networks. Just go to forwardnetworks.com/packetpushers. That's forwardnetworks.com/packetpushers. And now back to the podcast. Yeah, for sure. And you also mentioned that in Microsoft environments in particular, there may be lots of other EAP methods sort of auto-selected for you, presumably for backwards compatibility. Is that something folks should look at to be like, yeah, I don't want that one enabled?
Yeah, and there's, my slide deck, and anybody that's talked on this topic, I'm sure, and if you Google, you'll see deprecated EAP methods that are, not encrypted at all. Things like some of the MD5 old school mechanisms. I'm trying to remember the rest of that list, but there's some that are not ideal, and there's some that you absolutely should not be using. And if you see other stuff checked below the white box on a Microsoft NPS server, you probably want to uncheck that. And it's hard because what happens is none of that is clear. So nobody teaches it this way with inner and outers, and the vendors don't show you, they don't expose that necessarily. And so you don't know, Radius is hard to get set up the first time. When you're doing 802.1x, it's a lot of trial and error. I mean, I've done it a million times, and I don't think outside of maybe a lab or two have I ever, configured it and had it work perfectly the first time. It's always finagling things. And if you don't know what the different things are doing and you start just clicking and unclicking things and then suddenly it works, I mean, we all do this. You go, oh, okay, it works.
Don't touch it.
Don't touch it. Yeah, because you've already spent how many hours fighting with it, and it's just the reality. It's not what we should do, but it's the reality of what happens. You've been struggling through one little tiny thing for hours. You still have this long list of other stuff you've got to do and test and roll out. It works, and you were like, YOLO. We're just going to roll like this. But yeah, it is sending stuff in clear text when you do that.
Okay, that's good to know. Another issue you raise is the lack of support for AND statements. That's capital AND in 802.1x policies. What's the issue here?
Well, and this is another, Microsoft NPS thing, especially, and I mentioned that because this is, most organizations, if they've started their foray into Radius, that's where they're starting. And when we talk about logic statements or if then else type of statements, the some of the servers like Microsoft NPS for Radius don't support that. It's an or statement. And so if your intention as an organization, so I'm kind of aligning this to best practices, right? If your intention as an organization, we saw the nearest neighbor attack. The nearest neighbor attack we talked about at some point on one of the episodes of the podcast, but it's where an attacker in Russia was able to get into a VPN of a company that was kind of 2 doors down from the one they wanted to target. And they used scraped credentials from the internet because we don't use multi-factor on Wi-Fi. So if you have that MS Chat v2 and you're authenticating with username and password, and you don't have some way to verify it's your computer, then the nearest neighbor attack is possible. And so that's where they're hopping through different organizations that are geographically close, within Wi-Fi distance.
Okay.
And they've scraped credentials, so they've got username and passwords, so they get a VPN, a foothold through a VPN that's not secured. They get into that organization, they scrape the credentials from the next organization, and they take over one of the computers, and then they join the network at the next company from the computer that they have access to. And then they keep hopping through until they get to where they need to go. So it's really important. Now, it was already important before because you just didn't want personal users coming in and bringing their random stuff and getting on your secured 802.1x network, right, with the username and password, because there's nothing that stops them from doing that unless you are intentional. So if you want to say, look, authenticate and make sure it's Drew and Drew's on his managed computer.
Meaning I've got a 802.1x supplicant on that computer?
Yeah, but more importantly, that it's the company's computer.
Yeah, okay.
Not your personal computer.
Yep.
So that's what I mean by that and statement. You want to look, we typically want to look for, a user in this group that's authorized and the device. And if we can't do that, the next best thing to do is to issue a certificate to our device and authenticate it that way.
Okay. But you're saying we can't do that and binding?
Not in a lot of the Radius servers, and Microsoft NPS being the most notable. So if you configure something that says, hey, look for, a user in this group, and then look for, a computer in this group, it is an or. If you match either one of those, you're going to get on.
Okay. Does this then also apply to Cisco ICE and ClearPass, or?
So ICE, ClearPass, Fortinet, Forescout, all of the products out there that are kind of more like network access control products are going to give you full logic control. So, to varying degrees, but in all of those, you can most definitely say, and
you need to meet both of these conditions.
Yeah.
Yeah.
Now you can get, with some of those products, you can get pretty crazy with nested logic, and you can jump through a lot of authentication hoops with those things. But absolutely, which is one of the main reasons that I think a lot of organizations buy network access control products. A lot of times they get it just for that sort of, air quoting, advanced Radius service. Even if they're not doing other knacky type of things. It's like, hey, I need to authenticate with more specificity than I can get in a Microsoft service.
Okay. All right, our final Radius issue is not checking the server certificate. And yes, that sounds like a problem.
It does sound like a problem, but it's something we all do or have done. And I would say it's, one of the first things we talk about with that is like, typically when you first set something up and you're testing it and doing basic troubleshooting, it's an easy button to just go, don't validate the server certificate. But the truth is, I'm less worried about that, because typically if that happens, it's on an individual endpoint. What's a bigger problem is organizations that have, parts of their fleet that are not in the directory services. Let me use a specific examples here. So let's say you're a Microsoft shop. If you do certificates, even if you're not doing device certificates, regardless of the authentication mechanism for the user or device, the server has to have a certificate. So 802.1x prescribes mutual authentication, which means not only does the device or user have to authenticate, but the server has to authenticate itself to that user or device. And that's always with the certificate. So what tends to happen is if you're in a Microsoft environment, and whether you're using Intune Cloud PKI, or you've got CA services spun up on your on-prem, there's all of these little options to automatically enroll and automatically push certificates from your servers out to your endpoints that are in the domain structure. So if you have a computer that's in the domain, no problemo. But the minute that you have Apple's, Chromebooks, smartphones that are corporate owned. If you have those things going on and they're not in the directory structure, they're not automatically getting the server certificate pushed to them.
Okay.
And that's where like mobile device management tools come in, and we have to, configure a little policy that looks like a group policy kind of to push that to them.
Mm-hmm.
But that doesn't happen a lot, either because there's not MDM, or somebody didn't know to do it or how to do it, or there was, I've talked to people in the class that we were in a couple weeks ago, somebody said they found out accidentally that at some point their help desk had troubleshot an issue, and unchecking validate server certificate was the resolution for that particular user and issue.
Mm-hmm.
And so they actually rolled that into their standard configuration for all endpoints, because they didn't understand the impact of that.
Right.
So the why is that a problem? Because I'm big on like not security trivia, but like this is a problem, because the minute that you're not validating the server certificate, there is nothing stopping a malicious actor from doing an evil twin attack against your endpoints. And so that just means they look like they're your infrastructure, but you're actually connecting to a malicious, AP.
Right. So because the client isn't checking the certificate of the Radius server, it could be tricked into connecting to a malicious device.
Yes. And when I say malicious AP, it doesn't actually have to be a physical access point. There's software we can run on laptops that emulates an access point. As long as we have a radio and some software, we can do an evil twin attack.
Interesting.
So the Radius server certificate and an 802.1x secured network is your only mechanism to mitigate that.
The evil twin.
Yep.
Okay. Again, because it's doing that two-way certification. The Radius server is authenticating the client, but the client also has to authenticate the server.
Yeah.
And you want to make sure that second part is happening.
Yeah. And because if it's an evil twin and it's not your stuff, you are passing your credentials, and then you're passing your traffic to somebody else.
Yep.
So you've just lost integrity of that whole connection.
But you mentioned you found a case where this feature authenticate the server certificate was causing a problem. Is this a common issue that's going to throw up, more troubleshooting expense, or?
Well, yes, but I mean, not if it's designed properly, not if it's implemented properly. So the thing is any, the endpoints, I'm not talking about guest portals. I'm specifically talking about 802.1x right now, the Radius server certificate. The endpoints that are going to authenticate to that Radius server need to have trust for that Radius server.
Yep.
So the options typically, and when I say typically, the options with that WPA2 generation we've been using for 20 years have been, the user can accept the certificate that first time, or any time it connects, right? The user can go, so you'll like when you see a website and it says, hey, we don't trust this certificate. Do you want to add the certificate and trust it or not? So the same process happens if the endpoint doesn't already know and trust that certificate. The user can go, oh, it's okay. Yeah, just trust it. But you don't want that happening, because again, if it's an evil twin, the user doesn't know the difference between a fake certificate and the real certificate.
Right.
So that's not great. The other thing you could do with WPA2 is just say bypass server certificate validation. On the endpoint, you can tell it. So you could do this in a Windows machine, depending on if it's locked down with group policy. As the user, you could go in and tell it not to validate server certificate, or you can push that out through group policy settings. And you can do similar things on, like Apple and Android up to certain points. And then with WPA3 for enterprise with 1X, we actually have a little bit tighter restrictions on bypassing the server certificate. It's not removed completely, but it is restricted in some more meaningful ways, so that we can't just blanketly, always bypass the server certificate.
So in all the stuff we've talked about for the past almost 45 minutes now, I feel like could some of these things fall into the microsegmentation and zero trust network access buckets if you feel like I need a justification to start looking at and doing these things, or is that not a fair characterization?
Some of them definitely. I mean, the first section of some of those misconfigurations where we're lacking segmentation and visibility and control, but re-architecting. It's funny, I actually just did a webinar yesterday with NetAlly on zero trust for network engineers on LANs, like local networks and wireless networks, talking through why we can't do the things as quickly and easily as, zero trust and microsegmentation for data center workload and services and endpoints. Like why, if we're using the network to enforce that segmentation, why are we limited? How are we limited? And what is the future of that looking like from a product perspective? So yeah, some of this, definitely falls into that, but some of the 802.1x and radius stuff really just comes down to, following good hygiene, eating your 1x veggies, just architecting things the way that you're supposed to and being a good little network engineer.
But I feel like if, requiring the client to validate the server certificate does seem like a zero trust principle. I'm not going to just trust this server saying, yeah, I'm your radius server.
Yeah. No, I'm totally on board with that. Yes.
Okay. All right. So part 3, we just got a couple of other points we'll get through just so you know where we are in terms of time. So first up, we're talking about some vendor fails or some vendor issues in this section. First up, you recommend avoiding WPA3 personal compatibility mode at all costs. What is the WPA3 personal compatibility mode, and why did it merit your use of not 1, not 2, but 3 poop emojis in your presentation?
Oh man, it was funny because there was actually one of the engineering VPs from the Wi-Fi Alliance was in the audience. And he actually thought it was kind of funny. Okay. I'm going to keep this short, but don't get too twisted up with the words, but the words have specific meanings. So I mentioned that we have WPA3 generation of security, which is replacing this WPA2 generation. And I mentioned earlier that if we want to broadcast 2 and 3 on the same SSID, for a personal network, it might cause some problems. And I said there's a long list of reasons why with, multiple AKMs, blah, blah, blah. So that was called WPA3 personal transition mode. And I said the T and the M are capital. That is a mode defined by the Wi-Fi Alliance for interoperability. So that means we're broadcasting WPA2 and WPA3 personal on the same network. What should happen is an endpoint should look at that, and it basically sees two languages, right? French and English. And it goes, well, I don't speak French, but I speak English, so I'm going to do that. But if an endpoint is not conforming to the specification for 802.11, it may do different things. It may just go, there's 2 of them, and I don't like that, so I'm not going to attempt to associate. And there's so I'm using 2 AKMs as one example. There's like 4 different reasons or ways that an endpoint might misbehave. If it's certified by the Wi-Fi Alliance, if the endpoint is certified by the Wi-Fi Alliance, it is far less likely to misbehave like this. But a lot of endpoints are not certified. So if it's just been programmed to do whatever by whoever, then it might not be doing what it should be doing, and therefore it may not associate.
Okay.
So then JJ's personal opinion about fixing this problem is, well, have the endpoint vendors and those chip vendors do a better job at telling the endpoints to simply ignore the things they don't understand. Because that's the way these should work. Because now, with WPA2, WPA3, when we had fast transition mode come along, we have Wi-Fi 7 stuff that's totally different now. We have all of these extra things that are added, protected management frames. There's all this extra stuff advertised in beacons that an endpoint should just ignore if it doesn't understand it. So my feeling is the problem is the endpoints that are not performing to spec, that are not certified, go fix that. But some of the vendors decided, no, the thing to do is this compatibility mode, which basically makes the network look like a WPA2 network, relies on an endpoint being programmed to understand that there's this other override mechanism. And so there's another piece of stuff being advertised in addition to the stuff that was already confusing the endpoints.
Yeah.
And it tells an endpoint, well, if you can read me and you're capable, do better security. But if you can't, you do the old busted security that's been broken for 20 years. And my problem with that is so we took a problem and we just kind of compounded it. And now, because we're advertising the network as a lesser security network, if an endpoint hasn't been updated with this compatibility mode code, even a more capable endpoint is not going to know that there's a more secure option. So we've just kind of screwed ourselves both ways.
Okay. Yeah. Okay.
So I'm not a fan of that. That is a soapbox item for me. I see their point of view for certain residential use cases in certain parts of the world where people, like just home users aren't updating things or can't for a long time. But in most of the world, even in the home, we don't have Wi-Fi connected stuff that's 20 years old at this point.
All right. So the second soapbox issue in our last issue for the episode is you taking the Wi-Fi vendor community to task around Wi-Fi 7, meaning vendors are saying they're shipping Wi-Fi 7, but your contention is that it's not real Wi-Fi 7 because something is missing. What is missing?
All right. So there's a long list of things that are mandatory features in Wi-Fi 7. And Wi-Fi 7 is EHT, extremely high throughput, because they keep just adding superlatives to everything. So I'm not going to go through the whole list, but there are things like MLO, multi-link operation, which lets an endpoint establish communications potentially on multiple bands, 2.4, 5, and 6, and then switch between them as it needs to in an association. So that's required, even if it's single radio MLO, that's required in Wi-Fi 7. Another important thing is the cipher suite changed. We've used the same cipher suite. The CCNP 128 is an AES suite we have used since 802.11i robust security networks first came out 20 years ago. So we have used the same cipher suite. And when I say cipher suite, I mean this is the algorithm that encrypts the unicast traffic between an endpoint and an access point. So the over-the-air encryption for that device. We've used the same thing for 20 years. Wi-Fi 7 requires GCMP 256, which is a more efficient and more secure encryption algorithm. Now, there's also beacon protection frames. I don't even understand why we did that, frankly. There's separate keys for beacon protection frames in addition to the protected management frames. So don't worry about all these words, but there's a list of these things. One of the most notable things is that GCMP 256, because that applies to all Wi-Fi 7 networks. Doesn't matter if it's passphrase, doesn't matter if it's 802.1x. On a passphrase network, we also have a new AKM that's required to mitigate a specific vulnerability. So the spec says, and the vendors all say, hey, mandatory Wi-Fi 7 requirements, beacon protection, GCMP 256, AKM 24 on a personal network, blah, 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 blah. But we spun up stuff in the lab and nobody's actually advertising those things. They are advertising MLO with single radio. And then, so one of my friends was telling me about this wireless professional who is in London. He got on a hop-on, hop-off tour bus and rode around London with I think like an Echo House Sidekick or some type of wireless, tool, discovery tool, survey tool. Captured like 39,000 different networks being broadcast. A little over 1,000 of those were Wi-Fi 7. 0 of them had beacon protection.
Mm-hmm.
0 of them had GCMP 256. And I think less than 2% of them were advertising their required AKM suite for a passphrase network. So my concern is, because there's 2 things here. Let's just focus on the GCMP 256 thing for a second. I'm going to just push the other stuff away for a moment. Yeah. The endpoints are supposed to be programmed with orders of preference. Mm-hmm. So more secure and faster algorithms first, and then down for AKMs, and then for GCMP 256 versus AES 128. If they join with the Wi-Fi 7, it needs to be GCMP 256, blah, blah, blah. Mm-hmm. So the challenge is twofold. We haven't had endpoints dealing with 2 pairwise suites being advertised at the same time. So the Wi-Fi 7 capable AP that needs to do GCMP 256 for Wi-Fi 7, mm-hmm. it's still also going to advertise that AES 128. Mm-hmm. Because it can take Wi-Fi, 6 and 5 and whatever backwards compatible connections you let.
Yeah.
So it's advertising 2 pairwise suites. That has not been tested because we haven't done that for over 20 years. So we're going to have some endpoints. So if a vendor right now is not advertising these mandatory things to an endpoint, it looks and feels like a Wi-Fi 6 connection. Mm-hmm. But as soon as they start doing these mandatory things, we're going to see some endpoints that don't like 2 pairwise suites being advertised, just like we saw some that didn't like 2 AKMs being advertised. Mm-hmm, mm-hmm. And then what we saw in our lab testing is if you commingle the Wi-Fi 7 capable APs with Wi-Fi 6, some endpoints get really sticky. Actually, most of the endpoints that we tested, it's a small data set, but most of them got really sticky.
Meaning they just want to stick to the Wi-Fi 6 APs?
Well, so it's funny because I mentioned that order of preference for suites. Mm-hmm. So a lot of endpoints stuck on the Wi-Fi 7 AP.
Oh, really? Okay.
And there are endpoints that can do GCMP 256 on a Wi-Fi 6 connection. So that's a thing too.
So they stuck on the, were they sticking to the 7 because it was like, well, my instruction is to go for the most secure option, so I have to stay with this one? Okay. And the sticking issue is that performance could degrade because, a client may be sort of moving out of the best range of an AP, but it's stuck to that one because of other requirements, and so they're getting a bad connection.
Exactly. Mm-hmm. And when that happens, it actually impacts all of that airspace. Uh-huh. Uh-huh. If you have a slow client, because it's going to slow everything down. Mm-hmm. Mm-hmm. Now, we also saw endpoints do the other thing. So we had some endpoints that were from China, and I'm just it happened to be in this class. Those endpoints tended to not want to roam to the Wi-Fi 7 device. Mm-hmm. They preferred to stay on the AES 128 connection with Wi-Fi 6. So long story short, what my fear is that if the Wi-Fi vendors are, they're all talking about, X number of units shipped for Wi-Fi 7 and, how much adoption we have and blah, blah, blah. But it looks like it's still, for all practical purposes, is to an endpoint. It looks like a Wi-Fi 6 advertisement.
Okay.
And so my concern is if people do a little bit of testing and then they go deploy some Wi-Fi 7 in the middle of their Wi-Fi 6 things, it's going to work perfectly fine for a while. But the minute that code revs up and all of the Wi-Fi 7 mandatory features are initiated on that access point, now you're going to have problems. And so, my request of the vendors is you need to be clear about what you're doing and when you're doing to the users, or you need to just go ahead and bite the bullet. Because I think whether it's in the home or in the business, if we buy something new and we're like, ooh, Wi-Fi 7, and we put it in and we test, we expect to hit the hiccups then. Uh-huh. Not weeks or months from now when the vendor makes a change to the code version.
Right, okay.
We have enough other complexity and problems happening that we don't need that added on top of it. And the thing is unless you're in here, like I wouldn't have known unless I was running a lab in a class and looking at the beacon advertisements.
Mm-hmm.
But most people, now there's a lot of CW&Es and wireless nerds out there. Yes, you guys are doing this all day long, every day. But the other 99.99999% of enterprises out there that don't have an expert in wireless that's looking at this stuff, they're not going to understand what's happening.
Okay, that's interesting.
So I'm off my soapbox now. Done with soapbox.
Okay, you stepped down.
Or what did you call it a sandbox earlier?
Did I?
I don't know. It's been a week.
I think I said soapbox, but who knows? We'll look at the transcript.
I don't know. It'll be funnier if it was a sandbox. Keep me in my sandbox.
So, all right, this was really interesting, and I'm glad we had the chance to give you some more time to talk about stuff in this presentation, because you went through a lot in the video that's online of your presentation in about 20 minutes. So you had a little chance to stretch out here. And raised a lot of issues. So I hope folks have a chance to sit with this and digest it. And the fact is, we'll have a link in the show notes where you can actually also see JJ's slides if you want the visual, because that can help, particularly with some of the stuff you were talking about regarding some of these settings. We'll have that link. Check it out.
I just want to say thanks for having me. Maybe I'll be able to come back.
We'll see. We'll see. No, absolutely. Goodness. It was fun to put you in the interview seat and get to talk to you like a guest. So yeah, I hope you enjoyed it. Anyway, yeah, that does wrap up this episode. And like I said, we'll have lots of links in the show notes, including JJ has selected some of her favorite presentations from the most recent WLPC, in addition to her own, which we'll link there. And again, WLPC puts up all the videos, so there's a ton of stuff there. So go check out that YouTube channel. It's pretty intense. Thank you for joining us for this episode of Packet Protector. If you heard something that raised a flag for you and you want to follow up on it, hit us up, packetpushers.net/FU. We do love the follow-up, and we appreciate when listeners reach out. We're happy to get a correction, a question, a comment. And just to let you know, Packet Protector is part of the larger Packet Pushers podcast universe, where we've got 14 podcasts, all for your professional development on networking, security, IPv6, DevOps, and more, plus our industry blog, 2 weekly newsletters, including Human Infrastructure, which I work on with Ethan Banks, and every week we put together the most interesting blogs and news articles and vendor press releases that we find on the internet, plus some fun memes. You can sign up for all of this at packetpushers.net, where everything is free with no login required. As always, thanks for listening.
Hey, Drew.
Yeah.
Can we call it the Packet Verse from now on?
We might have to.
Yeah.
We might have
the
to.
Packet Verse.
That's good. That's good.
You're welcome, Ethan.
All right.
All right.
Packet Verse, here we come. Bye-bye.